Hundreds of feet below the surface, pressurized groundwater breaks through the rock face without warning. In seconds, a routine shift becomes a fight for survival. This is the dangerous world beneath the earth. Building the Gotthard Base Tunnel alone cost 9 workers their lives. Yet every day, crews still descend into darkness beneath mountains, rivers, and cities. What drives them underground, and what waits for them there? Millions of tons of overhead earth exert immense overburden pressure on a newly excavated space. Cutting into a mountain disrupts a prehistoric geological balance, transforming solid stone into an unstable zone prone to sudden rock falls and catastrophic cave-ins. Water is an equally persistent threat. High-pressure aquifers trapped behind rock walls can breach the excavation face in seconds, instantly transforming a dry heading into a high-velocity torrent. Beyond structural collapse, the air itself can turn lethal. Toxic and explosive gases, including methane and carbon monoxide, seep silently from rock fissures. This forces crews to run continuous atmospheric monitoring and heavy ventilation systems to prevent asphyxiation or ignition. Controlled detonations introduce further risk. Drill and blast methods demand absolute precision in charge timing and area clearance, as a single misfire or lingering charge can trigger secondary collapses. Beneath it all, the physical environment takes a heavy toll. Deafening machinery noise and heavy vibration wear on the human body day after day, while the confined, unpredictable nature of these underground spaces ensures that any unexpected geological shift can turn a routine shift into an immediate crisis. A typical 12-hour shift begins on the surface with a safety briefing and a detailed review of current geotechnical surveys. Workers study ground deformation logs and gas sensor readings before descending thousands of feet down access shafts via industrial cages. For crews operating a tunnel boring machine, the first 30 minutes are dedicated to systematic mechanical verification. Operators check hydraulic pressure, cutter head rotation systems, conveyor belt tension, and cooling water lines. Once cleared, the main drive engages, spinning the heavy disc cutters against the rock face. As the machine advances, the segment erector places precast concrete rings, while high-pressure pumps inject grout behind the lining to seal the structure. In sections utilizing conventional methods, the work follows a strict drill and blast cycle. Rigs drill precise patterns into the face, crews load the holes with explosives, detonate the charges in timed sequences, and then clear the fractured rock. After mucking, workers immediately secure the exposed ceiling with rock bolts, mesh, and robotic shotcrete sprayers. Throughout this entire process, continuous ventilation systems cycle fresh air through miles of tubing, and high-capacity pumps extract groundwater to keep the heading dry. Spoil must keep moving backward on conveyors while support materials travel forward. Beneath the physical routine lies a heavy psychological toll. Crews labor in constant deafening machinery noise and absolute darkness, illuminated only by headlamps. When the 12 hours end, the shift engineer records advance rates and equipment logs, preparing the incoming crew to take over the exact same ground. At the absolute front of the excavation, disciplined teams operate in tight, silent coordination. Drill and blast workers live closest to the face, drilling deep patterns and loading charges with precise delays to make the explosive sequence safe enough to repeat. Behind them, tunnel boring machine operators and front-end maintenance crews manage a massive, roaring machine that cannot be allowed to drift from its path, jam against squeezing rock, or overheat under intense friction. Shotcrete crews follow immediately, spraying high-pressure concrete onto the raw walls to stabilize the tunnel before the overhead ground can shift again. Every worker wears heavy personal protective equipment, from thick dust respirators to reinforced helmets operating under absolute concentration. Though their daily duties differ, these distinct roles share the same basic reality. At the face of a tunnel, a single underground mistake compounds fast, leaving no margin for error. Ensuring absolute alignment over miles of dark excavation falls to the surveyors. Using advanced optical instruments like the Leica TS16G and the SX12 scanning total stations, these specialists map coordinates to a fraction of an inch, maintaining millimeter-level positioning. Without their continuous guidance, a multi-million-dollar boring machine could easily drift off course and miss its target entirely. This demanding environment forged a distinct culture of underground labor, epitomized by the New York sandhogs of Local 147. For over a century, these crews have hollowed out the bedrock beneath Manhattan for subways and water tunnels, passing their specialized trade from generation to generation. For these modern miners, safety training, respirators, and heavy gear are not external rules to follow. They are core components of their professional identity. Survival in the dark demands absolute discipline, transforming protective equipment into a badge of membership in a proud, generational brotherhood that continues to reshape the city from below. The modern Gotthard Base Tunnel represents the peak of underground safety, yet the 17-year project still cost the lives of 9 workers. This loss stands against a grim historical lineage. In 1882, the original Gotthard Rail Tunnel claimed 199 lives. By 1980, the construction of the road tunnel in that same Alpine corridor cost 19 lives. Tunneling sits inside an inherently high-risk industry. In 2023, the construction sector accounted for 24% of all fatal work accidents across the European Union, while in 2024, the United States recorded 5,070 fatal injuries in construction. Underground, these general risks are intensified by unpredictable geological conditions. An academic review of tunnel construction history analyzed 206 documented accidents, demonstrating that serious failures are persistent geological challenges rather than rare anomalies. Even highly planned modern megaprojects face these realities. London's Crossrail, a massive urban undertaking, had to halt operations and adjust its engineering methods when workers encountered shifting clay, sand, and water-bearing strata. The geological conditions required real-time adaptation, proving that while safety systems have evolved to protect lives, the underlying forces of the Earth can never be fully tamed. Underground labor commands a premium, compensating for highly specialized skills and extreme environmental hazards. Base wages for experienced tunnel workers often reach $40 per hour, supplemented by up to $60 per hour in health, retirement, and union benefits. These rates scale across distinct pay bands, where overtime and hazard pay reflect the physical toll of the heading. This compensation is secured by strict training standards. Under federal guidelines like OSHA Standard 1926.800, safety is codified into mandatory education covering gas detection, structural support, and emergency egress. In jurisdictions with strict licensing, workers must pass formal exams on explosives handling and ventilation. This training turns danger into a series of disciplined, repeatable procedures. The final motivation is the legacy of the work itself, transforming brutal, temporary conditions into permanent infrastructure built to last for centuries. The scale of underground engineering is expanding to unprecedented depths. In Norway, the Rogfast project is carving the world's longest and deepest subsea road tunnel, plunging nearly 400 meters below sea level. Meanwhile, the Fehmarnbelt fixed link will connect Denmark and Germany by 2029 using a massive 18-kilometer submerged immersed tube system. These immense projects reflect a global demand for tunneling that shows no signs of slowing down. As drives push further beneath oceans and mountains, new paradigms like Hyperloop transit tubes introduce complex challenges, requiring advanced pressure management and automated evacuation systems to handle near-vacuum environments. To meet these demands safely, the industry is deploying autonomous boring machines guided by artificial intelligence, along with real-time sensor networks that continuously monitor ground deformation and air quality. Yet even as robotics and remote systems assume the most immediate physical risks at the excavation phase, the work ultimately depends on the judgment of skilled crews. Technology changes the tools, but the human element remains the true anchor of survival deep beneath the earth. As our cities expand downward and new transit frontiers emerge, the demand for deeper tunnels will only grow. Machines will advance, but the human element remains irreplaceable. Our future, above ground, relies on those willing to work in the dark. Share your thoughts on their sacrifice below.